Hello friends, welcome back. So today we will do replacement analysis problems, especially concentrating on replacement of equipment that fails suddenly. So what to do when any equipment fails suddenly. We'll see the theory, how to solve it, and we'll solve a problem there. So replacement of equipment that fails suddenly. It is difficult to predict that a particular equipment will fail. For example, uh, the bulbs in your house or anything which can fail suddenly. This difficulty can be overcome by internal probability distribution of failure. Now, assuming that failures occur at the end of period, say t, our objective in the problems is to find out the value of t, means when exactly they fail, how frequently they fail, which minimize the total cost of investment. So whenever we are doing the equipment that fails suddenly, we consider two policies: individual replacement policy and group replacement policy. So I'll give an example here. So how these two policies are followed together. Let's say you have constructed a new house and you have 10 bulbs fitted in your house. Okay, so you have uh, let's say after 1 year, 2 bulbs they go off. Okay, they suddenly fail. At that time, you will do the individual replacement. You will not do the group replacement, all 10 bulbs, but you will, whichever bulbs are not working, have failed, you will replace them. Okay, so that is individual replacement. Then after, let's say, after 3 years or so, you think of painting your entire house for maintenance purpose. When you have painted the entire house, some people, what they do is they will change the entire bulbs, all 10 bulbs, no matter whether they have working or they have failed. They they replace all the bulbs, all fresh 10 bulbs. So that is group replacement. Why they do it? Because now and then the maintenance will be a problem, so they completely change it. Now group replacement happens for a longer period of time. People don't care whether the individual bulbs are working or not. Whenever they're, or even if new bulbs have been fitted, they replace all the bulbs no matter what. So individual replacement and group replacement go hand in hand. So whenever we are solving the replacement problems which for the equipment that fails suddenly, so we need to find out when we will go for individual replacement and after how long we will go for group replacement. Which replacement policy is much better, also we will see in the problems. Now I have given the example of bulbs here. So let us solve one problem to understand how this thing works. Now here the following mortality rates, that is failure rates of bulbs have been given here. It has been observed for certain type of light bulbs. So this is data for 5 weeks and percentage of failings by end of the week, that is 10%, 25, 50, 80 and 100. So this we can see that it is cumulative in nature. This is not per week data, but each week has the previous week data also involved in it. Okay, so there are 1000 bulbs in use and it costs 2 rupees. So see here, it costs 2 rupees to replace individual bulb. Let's say out of 1000 bulbs, 2 bulbs fail. So you only change those 2 bulbs. So it will cost 2 rupees per bulb, means 2 plus 2, it will cost you 4 rupees, which has burnt out. If all bulbs were replaced simultaneously, let's say all 1000 bulbs are replaced, it would cost you 50 paisa per bulb. Okay, so it is proposed to replace all bulbs at fixed intervals. Means what they are saying is you need to replace all the bulbs at fixed intervals. You need to find out whether or not they are working or not. Right, you have to change them. So how frequently, when you should do the group replacement, and you should also continue replacing the bulb which are burnt as they are failing to work. In the sense, like every 3 years you are changing the bulbs, group replacement. Now today, if 2 bulbs are not working, you cannot wait for next 3 years to change them. You have to change those 2 bulbs as and when they fail. So the question is, at what intervals the bulbs should be replaced for even group replacement, and which is better, group replacement or individual replacement. So this is the question here. Anyway, we'll try solving this thing. So we have two types of data. That is, first thing is the weeks. We have first, second, third, fourth, and fifth week. Now percentage of failing of bulbs failing per week is given. Okay, this is percentage. That is, it is 10%. 25, then it is 50, 80, 100. Now, main thing is, when we got the percentage, we need to find out the probability that a bulb which was placed in the position for use fails during the ith week of life. In the sense, like, we need to find out the probabilities. Now, probabilities of bulbs failing per week. So we need to find the probability. Now there are totally probability is now 10 bulbs are failing. Okay, when it is percentage, if it is 10 bulbs, so 10 divided by 100%, that is 10% is nothing but 10 divided by 100, that is equal to 0.1. Similarly, for the second one, this is 0.1. For the second one, it is 0.25. Okay, this is for the first year, the P1. So for P2, it is actually 0.25. But this 0.25 includes this 10 also. So what we need to do is, we should deduct that, because this is a cumulative data. So we need to have the individual weeks data. So 0.25 minus 0.1, which is the previous weeks, will give you this week's actual work. So 0.25 includes total, including first week and second week, it is 0.25 bulbs are failing, the probability. So 0.25 minus 0.1 will give you 0.15. So for the third week, it is 0.5 minus the previous week, that is 0.2. That is 0.25. So it is 0.25 itself. Okay. So P4, that is 0.8, minus the previous week's is 0.5. So it is 0.3. And P5, it is total of 100 bulbs, so that means it will be 1.0 or 1 minus 0.8, which is for the previous week, will give you the last data. Right? So anyway, we have got the probabilities. Now if you total these probabilities, 0.1, 0.015, 0.25, 0.3 and 0.20, the total should be equal to 1.0. That means the 100%. So we've got the probabilities here, which is very, very, very important. Okay. So what I will do is, I will write these probabilities as PI column here in the corner, because I can use them. P1 is equal to 0.1, P2 is equal to 0.15, P3 is equal to 0.25, P4 is equal to 0.3, P5 is equal to 0.0. Okay, so I will take this off because I need more space to continue with the problem. Okay, so now I have got the probabilities of the bulbs failing every week. So for all the 5 weeks, 5 probabilities I have got. So next, I need, this is the step 1. Basically, what we have done so far is the step 1. Now, in the step 2, we will find number of replacements at the end of ith week. So in the step 2, we will find out number of replacement in the ith week. This number of replacements is denoted by Ni. So it is denoted by Ni. So let us take N0 as the number of replacements. Number of bulbs in the beginning. So I will write it here. N0 is equal to number of bulbs in the beginning. So how many number of bulbs were there? So there are total 1000 bulbs are there. So this is N0. I will write it because it should be visible. So this is N0. So now number of bulbs which are failing for the first week. Okay, I will take it as N1. Okay, for the first week, out of 1000 bulbs, means out of N0 bulbs, okay, pay attention here, out of N0 bulbs, P1 bulbs are failing, that is P1, that is equal to, out of 1000 bulbs, how many bulbs are failing? You can, out of 1000 bulbs, 0.1 bulbs are failing. So out of 1000, 0.1 is 10%. So how much it is? So 100 bulbs are failing for the first week. So similarly, if I take the second week for example, now what's happening is, for second week, now out of 1000 bulbs, out of N0 bulbs, out of 1000 bulbs, second week how many are failing? P2 bulbs are failing. Okay, but apart from this, plus, in the first week you have changed 1000 bulbs. Now these 1000 bulbs completed the first week. These 1000 bulbs completed the first week. In the first week of completion, out of 1000, 10% bulbs failed, means 100 bulbs failed and 100 you replaced. These 100, so these 1000 bulbs completed first week and second week. But these 100 bulbs completed 1 week, right? So that's why these N0 bulbs completed second 2 weeks. That's why it is P2. But these N1 bulbs, which are 100, completed 1 week now. Those 100 bulbs, in those 100 bulbs, again, P1 bulbs can fail. Means probability of failing for the first week. Means out of these 100, again, these P1 can fail now. So that's why what we have to take is N1 into N1 into P1. So N1 P1. So that is equal to, now if you see, 1000 into P2 is how much? 0.15. I'll just take this off. Plus this 100. In this 100 again 10% will fail. That is 0.1, which will give you 150. That is 0.1 of 15% of 1000 plus 10% of 100. That is 100. That's equal to 160. Now in the second week, 160 bulbs you are replacing. In the first week you replaced 100 bulbs. So in the second week you replaced 160 bulbs. Now let's go to the third week. Now these 1000 bulbs, N0 bulbs, are completing how many weeks now? 3 weeks. Now we need to see N0 into third week is P3. Okay, we'll write P3 here, plus. Now after N0, we should be worried about N1. These 100 bulbs completed how many weeks? First week, and this is second week. So N1 bulbs have completed. This is the first week they completed. This is the second week. First week P1 number of P1 failed. For second week P2. So N1, P2 plus. Now these N2 bulbs were replaced last week, correct? Last week. Now these N2 bulbs completed how many week? 1 week. So after 1 week, how many will fail? In these N2, that is out of 160, again 10% will fail. That is P1. Out of this 100, that is N1. In the second week, 15% will fail. Out of this N2, 160, again 10% will fail. So if you do this maths, it is 1000 into P3, that is 0.25, plus N1, which is 100, into 0.15, plus 160. Out of 160, how many will fail again? That is 10%. That is 0.1. So if you do this, totally 261 bulbs you are replacing. Sorry, it is 281 bulbs you are replacing here. Okay. Now, similarly, these continue. Okay. Now for the fourth week, N4. Now these N0 bulbs are completing the fourth week. So it will be P4 plus. Now N1 bulbs, last time it completed P2 second week. Now they are completing third week. Now N2, they completed last time first week. Now it will be second week for them. Now for these N2 is done. Now N3 is completing its first week. Now you know how to do the calculation right now. 1000 into 0.3 plus 100 into 0.25 plus 160 into 0.15 plus 281. These 281 bulbs are completing the first week. So that is 0.1. So if you do this calculation, so totally there are 379 bulbs which are being replaced. The 379 bulbs which are being replaced in the fourth week. Similarly, for the fifth week, So N1 will be completing its 4th week, N2 will be completing its this is N2 will be completing its 2nd week. Now N2 will be completing its 3rd week, plus N2 will become N3 will be completing 2nd week. Now N4 will be completing the 1st week. Okay, so if we do the same kind of calculation here, so totally 350 bulbs will be failing. Now you can see the trend here. Now I will write down how each week the bulbs are failing. Now I will write down the numbers here for your convenience, or else I'll write down here. So N1 is equal to 100, N2 is equal to 160, N3 is equal to 281, N4 is equal to 379, N5 is equal to 350. Now I'll take this off. This is the completion of the 2nd step. Okay, having the 2nd step completed, okay, now these are the number of bulbs which are failing every week here. These are the number of bulbs which are failing every week. So you can see here there is a trend which is going on. 5. Okay, so from 100 to 160 to 181. So it has increased the number of replacement to 379. So here you can see after 379 there is a slight decrease here. That is, the number of bulbs being replaced have been decreased. So slowly it increased here and it started decreasing. So there will be a cyclical trend up and down, how you actually replace the bulbs. Now based on the probabilities of bulbs being failing, now we got to know how these bulbs fail out of N0 bulbs, that is out of N0, that is 1000 bulbs. For the 1st week it is 100 bulbs which failed and you replaced individually. So these are the individual replacements what we have done. So now let us calculate in the step 3, we calculate the expected life of each bulb. So in step 3, we calculate the expected life of each bulb. So to do this, we basically follow a formula. Summation of I is equal to 1 to 5 IPI. So I is the number of weeks and P is the probability of failures. So it is nothing but for the 1st week. For the 1st week, how many bulbs are failing? It is 0.1. Okay. Plus for the 2nd week, for the 2nd week, 0.15 bulbs are failing. For the 3rd week, 0.25 bulbs are failing. For the 4th week, 0.30 bulbs are failing. For the 5th week, 0.20 bulbs are failing. If you do this calculation, so totally there are 3.35 bulbs is 3.35 weeks is the life of each bulb on an average. Now, if you calculate average number of failures per week, if you calculate average number of the average number of failures per week, okay, it is equal to, so let's take this out. So how many bulbs are there? So there are 1,000 bulbs. Out of 1,000 bulbs, the average life is 3.35. So average number of failures per week is equal to, it is 298.50. That is, you can say it is approximately equal to 299 bulbs. It is 299 approximately, right? So, so average number of failures per week, bulb failures, is 299 bulbs are failing every week out of the 1,000 bulbs. Now, out of 1,000 bulbs, now replacement for all 1,000 bulbs simultaneously cost you 50 paisa per bulb. Now, what we need to do is here, again we should go for the step 4. Now, we need to find out how much it will cost if we do the individual replacement. Okay. In the step 4, the cost of individual replacement we need to find out. The cost of individual replacement. The cost of individual replacement will be, as you know, the average number of bulb failure per week is 299 bulbs. Now, how much is for individual replacement? It is rupees 2. That is, I will write it as 2, just 2. That is how much you will be paying. So, cost of individual replacement will be 598 rupees. It is rupees 598. So, once basically once we have done this, okay, we have understood that we have got to know that, you know, the cost of individual replacement will cost you rupees 2, and if you are doing the group replacement, it will cost you 50 paisa. Right, so we know this, but when we are actually, let us put a table to understand how much it will cost for each week. For end of the week, okay, for end of week 1, 2, 3, 4, and 5, the individual replacement will be, for the first week, as you all know, it will be the 100 bulbs. Okay. For the second week, it is basically 100 bulbs. It is 100 bulbs plus 160 bulbs. So total, it is 260 bulbs. Now, if you see the third week, it is 260 bulbs plus 281 bulbs, that is 541 bulbs. Now 541 bulbs plus 379 bulbs will be 920 bulbs. Then total 920 bulbs, and the last one is 350, we will give you 1270 bulbs, which you are doing the individual replacement every week, and it's a cumulative figure. Now, what will happen if you are doing the total cost when you are doing the individual replacement as well as the group replacement? Now, this is the total cost. That is individual plus group replacement. Now, as we all know, the 100 bulbs, okay, so these 100 bulbs which are there for the first week, these 100 bulbs into these 100 bulbs will cost you 2 rupees for replacement. So it is 2 plus. Now if you want to do the group replacement of all 1000 bulbs, it will cost you 50 paisa, that is 0.5. Now totally it will cost you rupees 700 for the first week, if you are doing the individual as well as group replacement for the first week. Now if you do the individual with group replacement, 260 bulbs which are failing for the second week entirely, into 2 rupees plus 1000 into 0.5 will give you 1020 bulbs. You have to do the replacement of 1020 bulbs. Now for the third week, if you are taking 541 into 2 plus 1000 into 0.5 will give you 1582 bulbs, 1582 rupees. Okay. Now similarly 920 into 2 rupees, this is 922 bulbs into 2 rupees plus 1000 bulbs. If you are changing, then you have to spend around 2340. Then the last one is this. Actually, this is going out of my alignment. Just pardon me for that. So totally you have to spend 3040 if you're doing the individual replacement and group replacement for the 5th year here. Now, this is the total cost. This is the total cost. Now we need to find out the average cost. This average cost is given by, this is 700 is the total cost for week 1. So 700 divided by the end of the week. Average cost is equal to total cost divided by the week, which is n, small n. So that is 700, that is 700 divided by 1. This is 1020 divided by 2. 1020 divided by 2. I'll write it here, 1020 divided by 2, which will give you 510 for the second week. For the third week, it is 1582 divided by 3. It is 527.33. Now for the fourth week, it is 2340 divided by 4, which will give you 585. And the last week, 340 divided by fifth week, that is 608. Okay, these are the 5 weeks, and you have got the average cost. Now, average cost for the first week is 700. Now, the average cost is coming down to 510. Again, you can see that it is increasing, and still increasing. So, average cost comes down, and it goes up. So, second week is the appropriate time to do the group replacements. So, since the second week is the minimum time, the optimal replacement to have the group replacement is you will do the group replacement in the second week, because it is the least this thing. Now, since if you are comparing individual replacement with the group replacement, now group replacement, I will write it as group replacement GR, which is costing you average group replacement, that is 510 rupees. Now individual replacement is costing you, we have done it already, that is 598. So for the group replacement, it is costing you 510. For the individual replacement, we have done it already. I have taken this off, but you already know that it is 598 rupees. If you compare group replacement and individual replacement, group replacement is much cheaper than the individual replacement. So for this particular problem, you are going with the group replacement, which is much cheaper here. So average cost of individual replacement is average cost of group replacement policy is cheaper than the individual replacement, so we'll go with the group replacement policy. So this is how we need to solve the problem. Here we need to, in the conclusion, we need to write that group replacement can be done in the second week, and we also have to compare group replacement, average group replacement cost with the individual replacement, and see which is more preferable. And here in this problem, group replacement is more preferable. In this way, we need to solve the problem, and hence this is the solution. So we'll see the next problem in the next video. Thank you.